We are from the Roy's Academy faculty team, and today we're going to learn about a key topic in CBSE Class 10 mathematics. We're in Chapter 4, Quadratic Equations, and our focus is on factorization and the roots of quadratic equations. For similar video explainers, please connect with Roy's Academy at 891-0-890-311. I'll repeat that number, 891-0-890-311. Our other number is 891-0-600-503. Repeating that one again, 891-0-600-503. All right, so here's our game plan for today. First, we'll get a solid understanding of what roots really are. Then, we'll jump into the factorization method, our main tool for solving these equations. After that, we'll practice on some standard problems and even tackle a few that look a bit tricky. And finally, we'll connect all of this to a real-world problem so you can see why it's so useful. So, first things first, let's build our foundation by answering the most important question. What on earth is a root? Honestly, if you can grasp this one concept, the rest of the chapter just falls into place. Okay, don't let the formal definition scare you. A root is just a fancy name for the solution. It's the specific number you can plug in for x that makes the whole equation balance out perfectly to 0. You know, if you've heard of the zeros of a polynomial, it's the exact same idea. It's the value that makes the equation work. And here's a really important rule to remember. See that little squared in the term ax squared? That's your biggest clue. It tells you that a quadratic equation will have, at most, 2 roots. You might find 1, you might find 2, but you'll never find 3. That number 2 is the limit. All right, now for the fun part. Let's talk about the main technique we'll be using today, the factorization method. Think of this as your special toolkit for breaking down these equations and finding the roots hidden inside. It's really just a 4-step recipe. The absolute key, the most important part, is that first step, splitting the middle term. Once you nail that, the rest is pretty straightforward. You just group the terms, pull out what they have in common, and rewrite the whole thing as 2 simpler pieces being multiplied. And that last step makes solving it a piece of cake. Now, this idea right here is the magic behind why this all works. It's called the zero product property, but it's really just common sense. If you multiply 2 numbers and your answer is 0, well, one of those numbers had to be 0, right? There's no other way. And that simple fact is what lets us crack the code. Okay, enough with the theory. Let's get our hands dirty and actually put this method into practice with some real equations. Let's start with this one. 2x squared minus 5x plus 3 equals 0. Our mission is to find the values of x that make this statement true. Let's follow our steps. First, we need to split that middle term, minus 5x. We're going to split it into minus 2x and minus 3x. Now, why those 2 numbers specifically? Here's the secret. Our first coefficient is 2, and our last is 3. 2 times 3 is 6, and minus 2 times minus 3 is also 6. That's how we know it's the right split. From there, we group them up, pull out the common factors, and we're left with 2 beautiful, simple factors, 2x minus 3 and x minus 1. And now for the final easy step. Thanks to that zero product rule, we know that either x minus 1 is 0 or 2x minus 3 is 0. Solving those 2 tiny equations gives us our 2 roots, x equals 1 and x equals 3 over 2. And we're done. Perfect. Let's do just one more to really make sure this is locked in. Let's find the roots of 6x squared minus x minus 2 equals 0. The negative signs might look a little tricky, but trust me, the method works exactly the same. So once again, we split that middle term, which is negative x. This time we split it into positive 3x and negative 4x. Why? Well, 6 times negative 2 is negative 12, and 3 times negative 4 is also negative 12. See the pattern? After we group and factor everything out, we get 3x minus 2 and 2x plus 1. We set each one to 0, and we find our roots. X equals 2/3 and x equals negative 1/2. Simple as that. All right, you're doing great. But what happens when an equation looks, well, a little bit scary? Like, what if it has irrational numbers in it? Don't panic. Our 4-step process is more than strong enough to handle it. Take a look at this one. That square root of 6 sitting in the middle definitely looks intimidating. But let's just trust our method. We need to split negative 2 root 6x into 2 pieces. The most logical way is to just split it in half into negative root 6x and another negative root 6x. Let's see what happens. So when we go through the grouping and factoring process, something really interesting happens. We end up with two factors that are exactly the same. It becomes the square root of 3 times x minus the square root of 2 multiplied by itself. This is a special situation that we call repeated roots. Because both of our factors are identical, they're both going to give us the exact same answer. So even though a quadratic can have two roots, this one really only has one unique solution. Pretty cool, huh? So you might be asking yourself, this is all great, but when am I ever actually going to use this in real life? That is a fantastic question. Let's look at a practical problem to see exactly how this math applies outside the classroom. Imagine a rectangular prayer hall. We're told its total area is 300 square meters. We also know that its length is 1 meter more than twice its breadth. So if we call the breadth x, then the length must be 2x plus 1. And since area is length times breadth, we can set up our quadratic equation 2x squared plus x minus 300 equals 0. Now, all we have to do is what we've been practicing. We use our factorization method to solve for x. After we split the middle term and group everything, we get two factors, x minus 12 and 2x plus 25. And mathematically, this gives us two possible values for the breadth. X could be 12, or x could be negative 12.5. But hold on a second, let's stop and think. The math gave us two answers, which is fine, but we're talking about a real physical building here. Can the width of a room actually be a negative number? And this is where we have to use our brains, not just our formulas. The math gives us possibilities, but the real-world context gives us rules. A physical distance, like the breadth of a hall, can't be negative. It just doesn't make any sense. So we have to reject the negative answer. By throwing out the impossible answer, we're left with the only one that can be correct. The breadth of the hall must be 12 meters. And since we know the length is 2x plus 1, we can calculate that it must be 25 meters. And just like that, we've solved a real-world design problem. This was an initiative from the Roy's Academy faculty team. Today, we've learned about factorization and roots for quadratic equations in CBSE Class 10 Mathematics. For obtaining similar video explainers, please connect with Roy's Academy at 8910890311. Repeating the number again, 8910890311. Our other number is 8910600503. And one last time, 8910600503. Thank you for learning with us.